Something that's going to help us in our study of chemical bonding is knowing how to draw a Lewis dot diagram. A Lewis structure dot diagram is a short way to show the number of valence or outer electrons an atom has. And electrons are put into pairs around the nucleus of an atom. We have to remember that like charges repel each other, so electrons will spread out, if allowed, around the nucleus. Electrons are put in pairs on top of, on the bottom, to the left, and to the right of an element symbol. And the element symbol represents the nucleus and the electron energy levels except for the valence level. So if you look down here at this example, we have xenon, which is a noble gas, so we know it has 8 valence electrons. And typically when you plot electrons, you start with the first one here, and you're going to go into a counterclockwise fashion. So you're going to put your first one here, your second one on top, your third one to the left, your fourth one to the right, and then we're going to do it another round. So we put our 5th electron here, so our 1st and 5th electron will pair up. Then our 6th electron will go with our 2nd, so 2 and 6 will pair up. And then our 7th electron, if we had one, would go here, so 3 and 7 pair up. And then if we have an 8th electron, which means we're dealing with a noble gas, which xenon is, our 4th and our 8th electron would pair up. In order to learn how to diagram a Lewis dot diagram, it's really easy to go off of when we were doing Bohr. So if we take hydrogen, which has an atomic number of 1 and a mass number of 1, we know that it has 1 proton, 1 electron, and 0 neutrons. So if I have my nucleus, where my proton lives, and my first electron level with my 1 electron, that means I have 1 valence electron. And if I look at my periodic table, I see that hydrogen is in the first column, so it's in group number 1. When I draw a Lewis dot diagram, I'm going to write the element symbol, which for hydrogen is H, and I'm going to look just at the number of valence electrons. So if I have 1 valence electron, and I'm going off of my diagram here, if I have 1 valence electron, I'm going to put it on the right-hand side. So I'm going to draw it here, and then I'm done. You might be thinking, well, hydrogen only has 1 electron, so that's really easy. Let's go to carbon. If carbon has an atomic number of 6 and a mass number of 12, that means we have 6 protons, 6 electrons, and 6 neutrons. So if I draw my Bohr diagram, I have my protons and neutrons in the nucleus, and then I have the first electron energy level with 2 electrons. But if I have 6 total, that means I have 4 more, so I have to go to the next level. And I'll have my 1, 2, 3, 4 electrons that are left. So total, I have 1, 2, 3, 4, 5, 6 electrons, but only 4 in the outermost ring. So that means I have 4 valence electrons. Conveniently, carbon's also in the 14th column. So everyone in group 14 has 4 valence electrons. When I do my Lewis dot diagram, I'm going to draw the element symbol, which is C for carbon. And if I look at my model up here, we'll go 1, 2, 3, 4. We'll go all the way around. So with my 4 valence electrons, we're going to have 1, 2, 3, 4 dots. Next up is fluorine, which has an atomic number of 9 and a mass number of 19. So I have 9 protons, 9 electrons, and 10 neutrons. When I draw my Bohr diagram, I have my nucleus, and the first level, I'll max out my 2 electrons. But if I have 9 total, that means I have 7 more to go. So I need to draw another level, where I'll have my 7 remaining electrons. So I have 9 electrons total, but 7 in the outside ring. So I have 7 valence electrons. Conveniently for us, fluorine is also in group 17. So if I have 7 valence electrons and I want to draw a Lewis dot diagram, I'll write the element symbol first, which is F. And if I look at my model, if I have 7 valence electrons, I'm going to go all the way around. So 1, 2, 3, 4. And then I'm going to go for another turn up until 7. So 5, 6, and 7. Let's do that together for fluorine. So if I have 7 valence electrons, I'll say 1, 2, 3, 4, 5, 6, 7. And then I'm done. There's got to be an easier way to do this, and there is. We really wanted to make you have the connection between Bohr diagrams and Lewis dot diagrams before we gave you the shortcut. On the back side of your sheet, you'll see that we can go from the group number to the Lewis dot diagram. We've talked a lot how group 1 only has 1 valence electron, group 2 has 2 valence electrons. We skip the transition metals, which we'll get to in a second. So group 13 has 3 valence electrons, 14 has 4, 15 has 5, 16 has 6, 17 has 7 valence electrons, and 18 for the most part has 8, of course, except for helium. And we've already talked about why he is unique and an exception to the rule. If we look at sulfur on the periodic table, we'll notice that he's in group 16, which means automatically he'll have 6 valence electrons. So when I write my Lewis dot diagram, I'm going to write the symbol, which is S, and I'm going to do my 6 valence electrons in the order as prescribed. So 1, 2, 3, 4, 5, 6. Moving on to chlorine, he's in group 17, which means he's going to have 7 valence electrons if I look at my table up here. So my symbol for chlorine is Cl, and if I have 7 valence electrons, I have to put 1 on each side first. So now I'm up to 4, but I have 3 more, so I'm going to go around again and pair them up. So 5, 6, 7. So I have 3 pairs of electrons and 1 empty slot. Boron, we look at the periodic table, is in group 13. That means they have 3 valence electrons. So I'm going to draw or write my symbol, which is B, and for my 3 valence electrons, I'll have 1, 2, 3. So I'm always going to try to fill in each side with 1 first before I go back around. So I have 3 single electrons. Right now, pause the video and then do nitrogen and calcium on your own. When you've completed those, press play and then check your answers. Great! By now you should have tried nitrogen and calcium on your own. Let's go over them together. Nitrogen is in group 15, which means he'll have 5 valence electrons. So if I write down the symbol and I start on the right-hand side with my 5 valence electrons, I'll have 1, 2, 3, 4, 5 valence electrons. And then if I have calcium, which is in group 2, I'll have 2 valence electrons. So calcium's symbol will only have 2 dots next to it, and they'll both be single. We've talked a lot about how electrons are the most important part of chemical bonding, but these guys are always paired up. So sulfur can only bond with 2 things. Chlorine can only bond with 1, even though it has 7 valence electrons. Boron can bond with 3, and nitrogen can bond with 3 because these guys are already paired up. And calcium can bond with 2 things. And we'll go over that in more detail in our next target about ionic compounds. A lot of students ask about the transition metals, like, well, how are we supposed to know how many electrons they have if they vary? It depends on their charge, and that's usually given to us in the form of Roman numerals. The transition metals, which is groups 3 through 12, can have a varying number of valence electrons. So you'll usually see a Roman numeral in parentheses to indicate what kind of ion it will create. So the transition metals tend to lose electrons like the other metals, so they'll become positively charged ions called cations. So for example, copper with a Roman numeral 1 means it'll have 1 valence electron, while copper Roman numeral 2 means it'll have 2 valence electrons. Our example here is iron 3, and if you were writing it with a chemical symbol and a superscript, which we've already talked about, it would look like this, Fe plus 3. The group number, it's a transition metal, so we're kind of grouping them all together, and if it has a plus 3, that means it's going to have 3 valence electrons. And we're going to follow the same procedure. So we're going to write our chemical symbol. So we have Fe for iron, and if we have 3 valence electrons, then we'll do 1, 2, 3 dots.